Alright, this is PowerPoint on significant figures. So a significant figure is a digit in a measurement that is either a known or an estimate. So for example, 130.56, the 6 is an estimate, everything else is a known, has 5 significant figures. The 1, the 3, the 0, the 5, and the 6. Digits that are unknown are not significant. So unknowns are always zeros and are usually used as placeholders. So for example, 5,600,000 liters is 2 significant figures because the zeros are placeholders. Just the 5 and the 6 are significant. So what is a significant in a measurement? Non-zeros, so that's easy. 4.23, 3 sig figs. 129.46 is 5, and 765 is 3. Zeros between significant figures are significant. So 209 is 3, 40,098 is 5, and 30207.9 is 6. The last digit after the decimal is significant. So a 0 that is after the decimal and after a real number is significant. So 9.230 is 4, 23.3320 is 6 significant figures, and 1.20 is 3. Zeros in the scientific notation are significant. Again, it's after the real number. So 6.00 times 10 to the 9 is 3. 4.0 times 10 to the negative 4 is 2. What is not significant? So zeros that are used as placeholders are not significant. So for example, 0.0002 is only one significant figure because the zeros are before the value 2. 1,000 has 3 numbers after the 1, but no decimal spot, so only has one significant figure. Zeros that draw attention to themselves, like 0.12 or 0.243, are not significant. So 0.12 is 2 sig figs, and 0.243 is 3 sig figs. Again, the 0 has to come after a real number. A real number is anything 1 to 9. Alright, so what about adding and subtracting? So when you're doing a calculation, you need to round your answer to the least precise measurement. So basically, how many decimal spots you have. You always want to go to the least number. So we have 2.3 plus 1.2356 equals 3.5356. Now, since 2.3 only has one decimal spot, we can only go to one decimal spot on the answer. So it's 3.5. Precisions to the tenths. This is 10 thousandths. So unrounded answer. The correct answer rounded. We don't need a round because the number next to the 5 is a 3. So it stays at 3.5. When multiplying and dividing, you do your calculation first. And this is where you round to the least number of sig figs. So we have 5.7 times 456.345. We get 2,601.1665, and you can only round to 2 sig figs. So the 2 and the 6 are significant, the 0 is not. This has 2 sig figs. The 456.345 has 6 sig figs. This is your unrounded answer. And then for your Sig Figs, you have to only have 2 significant figures. Alright, things to remember. 0 used as placeholders are not significant. Addition, subtraction, you go to the least precise value. Multiplying, dividing, you go to the least number of Sig Figs. And you don't round until you finish your calculation. Alright, suppose you measured 8,000 liters and were sure of the 8 in the first 0. You estimated the second 0 and the last 0 is unknown. How can you show 8,000 has 3 Sig Figs? You can place a line over the 0. You can use significant notation, scientific notation, so 8.00 times 10 to the 6. If the 0 is in the 1's place, you can place a decimal after the 0. So for example, if it's 800 liters, you can put a decimal after it to make it significant. Alright, let me know if you have any questions. We'll review this in